All right, so I have on the board 3 indefinite integrals, 3 different ways of doing them, okay? The first one, and often students get stuck on the first one. When you look at it, your temptation might be to think, oh, it's got to be some sort of quotient rule or something. But anytime we can use algebra to our advantage, we want to do that. All right, so if I...
At this time, would you please release the JV boys baseball team? All JV boys baseball team, please release those students at this time. Thank you.
We realize we can do this, right, guys? And when we do that, and I'm going to take it right to rational exponents now, all right? I get the integral of x to the 3/2, right, minus x to the 1/2 dx. And how easy is this one now? I mean, this is an extremely easy integral problem once we make that separation. Now it's indefinite, so you're going to have plus c. Don't forget it. So what I get is x to the 5/2 over 5/2 minus x to the 3/2 over 3/2 plus c. And you can't leave it that way, right? You got to flip those bottom fractions, but again, I write it out. So yeah, you could have brought x to the square root of x, right? X to the -1/2 and distributed to both terms. Yep, and you get the same thing as this step right here if you do it that way. You're right. So I get 2/5 x to the 5/2 plus minus 2/3 x to the 3/2 plus c. And there's the answer. And that's an indefinite integral. And there's the steps I would do. Sam, you're right. So do that in blue. Well, if you bring up x to the -1/2, right, you get. Because I get 3/2. When I bring x to the top, it's x to the -1/2. Bottom to the top, because the square root of x is x to the 1/2 power. When I go from the denominator to the numerator, you change the sign. 2 minus 1/2 is 1.5, which I know is 3/2. All right, no problem. And again, if you bring it up like you were talking, you can do that, but when you distribute the -1/2, it goes to both terms. You end up with the same answer. All right? So there's the first one, and I'm going to get the view a little bit bigger. All right? The second one is probably the hardest one on the page. All right? You look at the problem, and your first instinct has to be to use U substitution. All right? You have to use U substitution here. And listen, we got to go with the U inside the radical. But remember, this is one of those cases where you got to be panicking right now, because we can see that 1 du is 4x cubed dx, and this is not x cubed, right? This is x to the 7th, it's a much higher order. But either way, I like to write out all these steps first, all right? So I pick my u, and I pick my du, all right? And I'm going to do a little separation here, and I'll start working this in green. I can see square root of u, you guys agree? And I'm going to separate x to the 7th into x4 and x3 dx, all right? And the reason I'm doing it this way is so that we can see that we're going to have x cubed here, all right? So I'm gonna need a 4, but if I put a 4 here, I got to put a 1/4 out here because it's one product, right? So I can balance 1/4 and 4 are 1. I can multiply by 1 anytime. And then what I'm going to do is I'm going to do another substitution. Well, this is du. You guys agree? But x to the 4th, we're going to have to calculate. Well, look at what happens when you solve this for x to the 4th. X to the 4th is u minus 1. So I can put u minus 1 in here. So if I redo this whole integral now, and I'm going to write it as u to the 1/2, u minus 1 for x to the 4th, and then du. And this problem is exact. Why did I rearrange it this step right here? I rearranged it because I had x to the 7th, Sam, and I didn't need x7 to get du. I only needed 4x cubed. Ah, okay. This is an equivalency exercise. So right now, Sam, these two are the same. Do you agree? These two are the same from here, okay? And this stuff is the same. And that all comes from your U substitution over there on the right. That's why I rearranged it, so that I could see this pop out. And at this point now, and this is section 5.5 in our textbook, at this point we can distribute, all right? And you're going to see something strangely familiar here now, right? Except the coefficient's going to be different this time. I get u to the 3/2 minus u to the half du. All right? Kind of reminds us of the last problem, doesn't it? So now we'll integrate this. U to the 5/2 over 5/2 minus u to the 3/2 over 3/2 plus c. And I'll just throw the plus c, because if you take a fourth plus c, right, it's still plus c, some constant we don't know. And I can't stop here. I'm going to have to substitute back in my u's and do some distributing. Nope, you could multiply it in. All right, it doesn't matter when, but the coefficient has to come out to be the same way either time. So my step now is probably I could change 5/2 to 2/5, right? Change 3/2 to 2/3. When I distribute, I get 1/5 u to the 5/2 minus 1/4 times 2/3 is 2/12. 1/6 u to the 3/2 plus c. You notice I left the u's out though, because I'm going to have to substitute back in for u. I'm at 1/10. Thank you. Good catch. My bad. Oh, yeah, it's 1/10. Second one is 1/6. Yep, because it's 2/20. So you guys are right. And there's the answer. And again, an indefinite integral always has a plus c. All right? Ah, because I took 1/4 times 2/5, and I got 2/20, which simplifies to 1/10. Because the 1/4 has to distribute to both terms, okay? This term and this term. All right? And there's lots of problems like these in the book to try if you need to practice a couple. The last problem here, this one is a little bit, again, not too bad. It's an indefinite integral. I'm going to extend the page here. This is a case of just doing the integral. There's three parts. First thing I probably would take time to do is to bring up the last one into the numerator, right? And from there, this is simply an exercise of integrating. And everybody, the 1/3 is a distractor. It's really common. The AP puts it there hoping you'll throw it away. Okay? The derivative of e to the x is e to the x. So the integral of e to the x is e to the x. The last one, we have to add 1 to the power, which makes it -2, not -4, over -2 plus c. We definitely have some simplifying that we're going to have to do here. So I would expect 1/9 x cubed plus e to the x plus 1 over 2x squared plus c. Because I would move x to -2 back and negatives cancel. And that is the integration of this indefinite integral. All right? Or some textbooks call it the antiderivative. Keep practicing those.